Hi everyone, my name is Rohan Singh Poona and welcome back to my channel. In this video, we'll be calculating time complexities of various code snippets. Time complexity. So let's start with one of the code snippets. Let's say we have for int I equals to 0, I less than n, I plus plus, and let's say we are just printing some value x, and that's all. Now, a lot of you might be already knowing that for a loop, you might just by looking at it, you might say that it's going to take big O of n time. But let's still, try to see why it's taking that much of time. So just by looking at it, we know that I is going to take values starting with 0, 1, 2, so on till n minus 1. Now for all of these values, we are going to print x, which is nothing but we are going to print x how many times? N times. And I is going to take values starting with 0 till n minus 1. It is also going to take value n, for which this particular condition will be satisfied as false. So the time taken here would be ideally the sum of both of them, which is nothing but it will be, this is nothing but n plus 1, and here we are printing n times, therefore it's going to be 2n plus 1 time. Therefore, the time complexity here is going to be big O of n, or we can say theta of n, or omega of n. In this case, all three are going to be same. Let's look into another code snippet. Let's say now we have for int I equals to 0, I less than n, and I plus equals to 2. Now in this case, let's say again, we are just simply printing x. Now, if we again, try to evaluate what all values I is going to take, I is going to start with 0, 2, 4, 6, and so on till n by 2. Right? It's also going to take n by 2 plus 1 value, right? And for which the condition, okay, so it's not going to take n by 2 plus 1, basically it's going to take value as अच्छा यहाँ ये गलती है, I got it. Now let's say we know that I is going to take values starting with 0, 2, 4, 6, and so on, right? So it's also going to take a value where नहीं यार इसमें क्या हो रहा है, basically 2 n क्यों नहीं हो पा रहा है मेरे से. Now we know that I is going to take values starting with 0, 2, 4, let's say 6, and till a point n for which this will become false, and then it will come out, right? So it's going to take n by 2 plus 1 values. And similarly, we'll be printing x how many times? In this case, n by 2 times. Therefore, the sum is going to be the time taken here. Therefore, it's nothing but n by 2 plus n by 2 plus 1, which is again going to be approximately, we can say that it's going to be n. Therefore, the time complexities in this case is going to be big O of n. You can say theta of n as well as omega of n. Let's jump on to another code snippet. Let's say that we have for int I equals to 0, I less than n, I plus plus, and let's say for int j equals to 0, j is less than n, and j plus plus. Again, we are just, let's say, printing some variable x, and that's it. So now if you observe, it's nothing but we are going to have I first as 0, and for this I equals to 0 we are going to have j starting with 0, 1, 2 till n minus 1, and it's going to also take the value n for which it will be false. Then again we are going to have I, and obviously like after this we are going to print x n times, and j will take n plus 1 values. Now I is going to be equals to 1, j is again going to be same, 0, 1, 2 till n minus 1. It will also take n as a value and it will fail, and for these n values it will print x n times, and this will basically, j will have n plus 1 values, and I will be equals to 2, so on. I will be equals to n minus 1, for which again we will have j starting with 0 till n minus 1. It will also take the value as n, basically n plus 1 operations here, and it will print x for n times, and I will be equals to n, for which it will be false and we will come out of the loop. So this I equals to n, for this we are just going to have 1 unit of time, as we are not actually having any values of j in this case. Now the time taken is nothing but is going to be the sum of all the operations. So for I equal to 0 we are doing how many operations? N plus 1 and n operations to print the value of x. So we are doing 2n plus 1 operations. For I equals to 1 again we are doing 2n plus 1 operations. For I equals to 2 also 2n plus 1 operations, and so on. For I equals to n plus n minus 1 we are again doing 2n plus 1 operations. For I equals to n we are not doing any operations, which is nothing but 1 unit of time. So if we observe that from I equals to 0 till I equals to n minus 1, we are doing 2n plus 1 operations for every value of I. So from 0 to n minus 1 we have totally n values of I, for which we are doing 2n plus 1 operations. And for I equals to n we are doing 1 operation, which is nothing but 1 unit of time. So we can say that the time taken is nothing but n into 2n plus 1 plus 1 time. If we actually open this particular equation, if we try to expand this equation, it's going to be 2n square plus n plus 1, which is again a quadratic equation, and we know that we can come up with a function g of n such that c into g of n is going to be the upper bound. So we are going to have the time complexity as big O of n square in this case. Yeah. Cool. So let's jump on to next problem. Let's say now we have the fourth problem. Let's say this time we have for int I equals to 0, I less than n, I plus plus. Let's say we have for int j equals to I, j is less than n, and j plus plus. Now let's say we are printing x, or we can say we are doing some big O of 1 constant operations in this case, or printing x is the equivalent anyways, print x, let's say, and that's it. Now let's try to evaluate again. For I equals to 0 we are going to have j equals to, starting from I, which is nothing but 0, 1, 2 till n minus 1, and it will also have the value n for which it will break, and we will basically print n times, print x, which is going to be n times, and then again for I equals to 1 it is going to start with j equals to 1, since j equals to I in this case. 1, 2, 3 till n minus 1, it will have n. Now for I equals to 2, we can actually ignore the print x because it's gonna be constant time, big O of 1, so it's not gonna contribute much, but still we can also accommodate if you want, it's fine. Let's say j equals to, for I equals to 2 it will be j equals to 2, 3, 4 till n minus 1 and n. Now again for I equals to 3 it will be j equals to, starting from 3, 4, 5 till n minus 1 and till n it will have n, and so on. Now when I will be equals to n minus 1, j will be equals to n minus 1 and then n, and it will break, and I equals to n, it will not function, right? So again if we try to compute the time complexity in this case, ideally it's going to be the sum of all of the operations that we are performing in this case. So if we try to calculate the sum here, then we know that for I equals to 0 we are performing We are printing n times and we are performing n plus 1 operations here. So it's gonna be totally 2n plus 1 operations. Now, for now, let's try to ignore the print x part because it will make it difficult for you to understand or compute, right? Let's say n plus 1 and n times. Now, if you see, let me remove this better, right? We know that it's gonna do n plus 1 times of iteration. Now, j is gonna start from 1 and it's gonna go till n minus 1 and n. So it's gonna have n values starting from 1 to n. Then again j is being reduced and j is starting from 2. So it's gonna have n minus 1 values. Now j is starting with 3 and going till n, it's gonna have n minus 2 values, n minus 3 values, and so on. For n minus 1, I equals to n minus 1, j is gonna have only 2 values, and then for I equals to n, we are gonna have only one computation, right? So if we see here, right, so how it is going on, it will be 2, it will be 3, 4, and so on. So if we see, the time taken here would be ideally the sum of all of these. And if we try to observe what are we trying to add here is nothing but, it's nothing but the natural numbers 1, 2, 3, 4 up till n. So we are trying to sum up numbers up till n plus 1 in this case, right? So we know that the sum of n numbers, you can say, is nothing but n into n plus 1 by 2, which is approximately, I mean, as we are ignoring some print x values which are nothing but taking big of 1 constant time, so I can say approximately it is taking n into n plus 1 by 2 time. If you open the brackets, you can see that it's nothing but a quadratic equation again, and therefore the time complexity of this equation is also going to be big of n square. I hope it's clear. If you guys have any doubts, anything, do comment down below, and I'll be happy to answer. And let's move on to the next code snippet. Let's say the fifth code snippet. Now let's say we have for int I equals to 0, I less than n, and let's say I by equals to 2, such that again let's say we are just printing x, and that's pretty much. So now I would like you guys to stop the video for a moment and try to calculate the time complexity, and let's see you are able to calculate it correctly or not. Seriously, just try to pause the videos, guys, and do try to compute this. So I'll just count till 2, 1, 2. I hope you guys have tried, and let's see what's the time complexity in this case. So if you see here, right, we can see that I is going to take value as 0 first, and obviously it will satisfy the condition, we will print x. Now we are seeing that we are dividing I by 2. So 0 by 2 is again going to be 0. So I will still be 0, and we'll again print x. Now again we'll divide 0 by 2, it's again still going to be 0, and we'll print x. We'll keep printing x. Therefore this is going to take infinite time. So I'm sure that you guys have given a try and must have observed that, you know, we are not reducing the value of I, and neither we are increasing the value of I. I mean, it's just remaining the same, and we're continuously printing x. Cool. Let's jump on to next code snippet now. Let's say we have now for, this is the sixth code snippet, for int I equals to, let's say n, I is greater than equals to 0, and let's say I by equals to 2. Now let's say again we are just printing x. Now if we observe here, we can see that I is going to take value starting with n. I is going to start with n, then I will have the value as n by 2, I will have the value as n by 4, I will have the value as n by 8, I will have the value as n by 16, and so on. At one point in time it might have a value as 1, and the last value that it can have is I greater than equal to 0, so 0, and then it will just break, right? Let's say not I greater than equal to 0, better let's have I greater than 0, because again we will keep dividing by 0, so it will never be, you know, completing, and it will just, you know, stuck under infinite loop. So we will have I starting with n till 1. So in this case, for I equals to n, we'll print x. For this also n by 2 will print x, will print x, will print x. Let's say all of this takes 1 unit of time, 1 unit of time, 1 unit of time, again 1 unit of time. For this also 1 unit of time, so on till this one. For this also 1 unit of time. Then ideally the time taken is nothing but the sum of all these 1 units of time, right? So, but we don't know how many 1 units of time are there. And this is the challenging part here, that if we can count the number of ones in this, then that's gonna be the time taken, right? So one observation that we can make is, if you actually look at these numbers, the values that I is actually, getting initialized with is nothing but n, then n by 2, n by 4, n by 8, n by 16. If you see these numbers, these are actually running in the power of 2's. So we can also rewrite this as n by 2 power 0, and n by 2 as n by 2 power 1, n by 4 as n by 2 power 2, n by 2 power 3, n by 2 power 4, and so on till 1. For 1, obviously we'll have something n by 2 power something which should be equivalent to 1, and we don't know what's the power of it. Let's say that the power of it is, let's say for now, k, right? So can I say that this particular one is nothing but the 0th one, and this one is nothing but the first one, this is nothing but the second one, this is nothing but the third one? Can I say that the powers here are equivalent to counting the ones? If we have k ones, I mean 0 to k, that means we are completely, totally k plus 1, or you can say like we are actually, printing x k plus 1 times. So if somehow we knew k, then I can say that I am able to count the number of times I have printed this x. Now what and how can we find this value of k? See, one observation that we can make, that the last value is nothing but equal to 1. So what we know is that n by 2 power k is nothing but equals to 1. We can do simple cross multiplication and we can see that n is nothing but 2 power k. Now we need to find the value of k. One simple thing that we can do is we can just simply take logs on both sides. We can take log on both sides. It's nothing but log here and as well as log on this side. Now we know that we are dealing with the number 2. So the property of log is nothing but, there are a couple of properties of log. I would just write down a few which are being used here. One is that log base 10 for 10 is nothing but equals to 1, which is nothing but if we have log base b is gonna be 1. So we know that this is 2, and if we take a log base 2, then 2 is gonna be 1. But one more property of log is log a power x, any base, let's say b, right, is gonna be x log base b a. Therefore I can say that this is gonna be k log base 2 2, and log base 2 2 is gonna be 1. So can I say that k is equals to, since I have applied log base 2 on the both sides, k is equals to log base 2 n. Therefore we know that we are printing x k plus 1 times, which is nothing but the value of k here is log base 2 n plus 1. Therefore the time complexity in this case is nothing but, it's gonna be big O of log base 2 of n. Yeah, I hope this will be clear. Let's jump on to one more code snippet. Yeah, let's say this time we have for int I equals to n, this is the 7th code snippet, and I greater than 0, and I by equals to 2, and for int j equals to 0, j less than I, and let's say j plus plus. Now again, let's say we are doing some operation, some constant operation big O of 1, which can be ignored. Let's say it is not contributing any time to the time complexity, and that's it. Let's again follow the fundamental basic steps, right? We can see that I is gonna be starting with n, right? Okay, before we actually try to calculate, I would like to say something here, which is nothing but if someone would have just taken a look at these two for loops, or even you, if you are someone who is new to learning this time complexities, then someone like you or some other folks, what they do is just by looking at two for loops, they would say that this particular piece of code is gonna take big O of n square time. Since two for loops, so n square, which will be completely wrong in this case. And why it will be wrong? We will just look at it and we will be deriving how much time this particular code snippet is going to take. So, okay, let me remove this and let's say I is going to start with n. Now for I equals to n, we see that we have value of j ranging between 0 to less than I, and j is incrementing 1 by 1. Therefore, for I equals to n, we will have j equals to 0, 1, 2, till n minus 1, and also n for which it will be false, right? Now I will be divided by 2, therefore I will have a value which will be n by 2. Now for this I equals to n by 2, j will be starting with 0, 1, 2, it will go till n by 2 minus 1, and it will also go with n by 2 for which it will be false and will come out. Now we will have I equals to, again I will be divided by 2, that is n by 2 will be divided by 2, which is nothing but n by 4. So j will be starting with 0, 1, 2, it will go till n by 4 minus 1 and n by 4 for which it will be wrong and it will come out. Same way I will again go for n by 8 and so on, and I has to be greater than 0. So I will reach up at a point for which it will become 1, and for I equal to 0 it will be false, and that's it, right? So now the time complexity for this code is gonna be nothing but if we just add all the operations, then we are gonna get the answer. So here we are gonna have for I equals to n, how many operations we are gonna have? 0 to n minus 1 and n, which is nothing but n plus 1 operations. Now here we are gonna have n by 2 plus 1 operations. Here we are gonna have n by 4 plus 1 operations. Here for n by 8 we are gonna have n by 8 plus 1 operations. So on, 1 plus 1 operations and no operations, right? So we can see that the sum of all of this is gonna be, obviously this 1 is a constant, either we can add or we can ignore. For now let's it's our wish, but still I'll not ignore for you as you're learning it for the first time. So we can say that we are gonna have n, so the time complexity is gonna be sum of all of this, right? So if I write down in simple words, then it's gonna be n plus n by 2 plus n by 4 plus n by 8 plus so on till 1, plus we have, let's say once, let's say c times. Let's say we have c times, we don't know how many times, let's say it's c times, right? Now we are gonna have something like this. So this is gonna be the time complexity. So we don't know what's the exact value in this particular case, right? So if we again try to observe these numbers, then we can say that these numbers, the n is decreasing by a division of power of 2. So we can also write this like n by 2 power 0 plus n by 2 power 1 plus n by 2 power 2 plus n by 2 power 3 plus so on till a particular point in time when it will become 1, plus we have c times 1, let's say. It's a constant, so we can actually ignore this for now, right? Let's focus here. So we see that we have some sort of a series which is nothing but this. So if we are able to compute the sum of these terms, then we can say that that is the time complexity. So this is nothing but the sum of infinite GP or geometric progression. In this case, the common element that we have across which can be taken out is nothing but n in this case, which is a, and we have the common ratio between all of the elements as 1 by 2. So the formula for sum of infinite GP is nothing but a by r minus 1. If you guys remember mathematics, or like for now you can just refer this particular formula here, right? No need to go in depth, but yeah, the formula for this is going to be a by r minus 1. Therefore, if we apply this particular formula here for the sum of infinite GP, then what do we get? A is going to be n in this case. So a is going to be n, r is nothing but 1 by 2 minus 1, which is nothing but, if we actually just cross multiply, okay, my bad, it's not r minus 1, it's 1 minus r. Yeah, so it's gonna be 1 minus 1 by 2, which is gonna be again half, so it's gonna be n by half, which is nothing but 2n. So the time complexity for this particular code snippet is nothing but big O of n, obviously plus the constant, let's say 1, right? So it's gonna be big O of n. Like, no one would have actually imagined, just by looking at this particular code snippet, that the time complexity for this code is gonna be big O of n and not big O of n square. That's why just never have this with yourself, that if there are one loop, big O of n, if there are two loops, big O of n square. That can be completely wrong. So this was very important piece of code for which I wanted you to analyze the time, and I hope this helps. And these are the various types of like code snippets that you can come across, and I can assure you that if you are able to solve all of these, then you will be able to calculate time complexity for any piece of code that you're going to write, maybe in your career, I can say, or otherwise if you're studying in college or anywhere, then obviously you'll be able to compute the time complexity of any piece of code that you're going to write. That much I can assure you. Yeah. So in the next video, we'll be looking into what is a recurrence relation, and we'll be looking into something called as Master's theorem. And yeah, that's pretty much for this class. Stay tuned and thank you.